Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Mohammad Shahriar, almost like a Mithil, and a CSF ambassador. I will be your host tonight. Every week, we bring a new set of presenters to showcase how to work with Cloud Native technologies. They will build things, they will break things, and they will answer your questions. In today's session, I'm stoked to introduce Saim Safdar, a developer relations manager who will be presenting on mastering Kubernetes access management. This is an official live stream of the CNCF and such is subject to the CNCF code of conduct. Please do not add anything to the chat or questions that would be in violation of the code of conduct. Basically, please be respectful to all of your fellow participants and presenters. So, with that, I will hand it over to Sam Safdar and kick off today's presentation. So, let me add Sam to the screen. So, hey Sam, how are you?
Thank you very much, Sharia, for actually inviting us on this wonderful topic. And thank you very
Yeah.
much to the folks who actually just joined us on the chat. Hello, Ahmed. Hello, Manish. And hope you can actually able to hear me. And if you see some of the noise or anything bad happen during the presentation, do let me know. And once again, thank you everyone for joining. So my name is Saim Sabdar. As Sharia, we're the fellow CNCF ambassador, and it's been the first time we're actually interacting on the live stream. It's been a great story. It's going to be a good session to forward. So today I'm talking about Kubernetes access management and why you need to take into the consideration while you're actually working with the Kubernetes cluster on daily basis. I saw some of the challenges, and I look forward to tell you some of the challenges I faces and how I overcome some of those. So over to Nuna is you now, Shariar, and then share screen, and then I will start the proceeding.
Yeah. Yes, sure. Okay, so I guess we can
Oh,
start.
yes, absolutely. Thank you very much. Once again, I see more folks in the chat now, and I hope and everybody can able to see the slide right now. If you don't, please do let us know. So that is actually the agenda of the topic today, mastering Kubernetes access management. And we are watching Cloud CNCF Cloud Native Live. So I want to, can you go to the next slide to Sharar, please? So as I said, my name is Saim Safdar. I live in Pakistan, currently in Rawalpindi, and I am a CNCF ambassador. And it's been a wonderful journey so far right now. So can you go to the next slide, please? So what is the agenda today for the discussion today? We will talk about Kubernetes platform because there's a lot of moving pieces, and access management is one of those. And then we talk about share responsibility access matrix, a key consideration for multi-tenant or the cluster-based access management. I will let you know about the security lifecycle management of Kubernetes. If you're developing app on Kubernetes, there are some very overwhelmingly complex summary of requirements, and there's the control access. We're talking about some of our solution to our solve some of those. There's a demo I prepared with you and some highlight to let you know. At the end of the day, we will cover all these highlights in detail. So can you go to the next Shariar? So currently, if you look at the Kubernetes platform in general, you see automation, security, visibility, and governance. And that is bare minimum to have. I can expand it to the more further, but I believe these are the actual cornerstone of every Kubernetes or infrastructure if you're actually developing app on top of it. So there are two things you'd worry about. There's a modern lifecycle management, and there is a Kubernetes infrastructure management lifecycle. So basically, if you're working on Kubernetes today, might be you're using on data center, might be you're using Kubernetes on their on-prem data center, or might be you're using Kubernetes on EKS, Azure on AKS, might be you're using GKE, or might be you're using remote or edge cloud. So if you're in the Kubernetes space, you see the requirements are you need to build in automation. You have a security in place that we call it zero trust, and we call it a security preparedness. And then you need a visibility because you have app team, you have FinOps team, you have product team, you have marketing team, and you have a bunch of other team, and you want to provide them a visibility so they can look at the platform and everybody can separate the concern between what they are doing and what the other team members are doing in the shared platform. And then we need a governance. Governance basically mean when you do something, you need to take into the consideration, like I am allowed to actually change the cluster. If I am, how much of the access I granted, or even you can take a look at the Kubernetes and tools like Open Policy Agent and Policy and Governance. Those are the basic governance need. But I will talk more about these four considerations. But today, my focus is, can you go to the next slide, please, Sharyar? Yes. So basically, if you look at the summary of the requirement of the platform need, that the platform is now composed of not one, but there are so many moving parts right now. So, Shara, can you go to the next slide, please? Because I see the previous one. Can you go back? Yes, I can see it. Thank you. So basically, if you look at the platform today, and the previous one, Shara, the previous one. Shaya, can you go back to the previous slide?
I guess let's wait a bit because our speaker has been stuck in the net. Mm, let's see. So yeah, hello everyone from Israel, Iran. Okay, so let's wait a bit because our speaker has been actually disconnected from us. Let's wait. Let's see. Mhm. Okay, stop sharing. Okay,
Sorry, sorry.
yeah,
Sorry, I think
yeah.
I click a wrong button. Sorry for that. So yes, summary of the
Sure.
requirement in the platform need. Yes, that's the slide. Think yes, yes. So if you look at the platform today's, you need these major five, six cornerstone. You need a service mesh. You need network policies. You need zero trust access. You need policy and governance, policy enforcement. Then you need GitOps for drift detection, and then you need multi-tenancy because developers and the operations might there you have tens and hundred of teams, and by giving everyone a new cluster can't be overwhelmingly complex. So what you do is you share the cluster with the team member, so everybody using the same cluster. So that is a summary of requirement for the platform need. You need service mesh for managing logs and application and have a better separation of concern. You have zero trust access, how you can actually enable everyone access the resources. You need GitOps for the drift detection, and then you need policy enforcement, meaning you have a cluster is in place, and what the cluster is doing, you have some access to it, and you want to fine-grained, and you don't allow, as you do Kyverno open policy agent is feasible here. So Shadar, can you go to the next slide, please? Because that's where we are talking about shared responsibility access management. If you look at the Kubernetes plus cloud and the traditional cloud, in the traditional cloud, we have physical infrastructure, networking, virtualization, guest OS, application, data, user access, and identity. That is enough for you. And then you apply application start and you add binaries and Linux operating system, and you can add more into it. But that's a bare minimum you have to take into the consideration. Look at the Kubernetes plus cloud model. You have physical infrastructure, networking, virtualization, guest OS. Then the guest OS, then you install Kubernetes on top of guest operating system, meaning you have Linux installed on top of it. and then you have a Kubernetes infrastructure layer. And look at the Kubernetes, what Kubernetes does for you. You have CNIs, container network interface. You have CRIs, container runtime interfaces. You have container storage interfaces. Then you link up service meshes, GitOps, policy and governance, multi-tenancy, runtime detection with Falco, observability with Grafana and Prometheus, and for all the bottom layer to the top, you need a supply chain security tooling, making sure the container images that are actually you are using have actually this, they have secured version, not a major one, so a very less surface area of attack. So that's a big model now. And then you actually you as installing your app, and then you actually working with your app. So look at the model right now, and the access management become way harder right now. How much the access your app team has compared to the how much of the access your DevOps team have. You have to separate the concern between both of the infrastructure, and one bad command, then the forensic start, and the forensic is overwhelmingly complex to understand who does what. So Shadar, can you go to the next slide, please? Yes, can you? Yes, absolutely. So if you type a one bad command in anywhere, then there is a hustle, and then there is an immediacy around who does what, and you start doing some kind of forensic analysis, and the forensic is become very difficult because you have a CNI layer networking. Is it something complicated, or is something broken in the network layer? Is it something broken in the runtime layer? Is it something broken in the storage layer? Is it something broken in the service mesh layer? So battling for the root cause is not easy. It's very difficult. So today is my focus is to reduce some of the concept around security and how app life cycle management work. So in app lifecycle management, you need zero trust application deployment, meaning when you when you actually type a command, kubectl get nginx, meaning you have access to the cluster that are actually provided to you by the DevOps team, and you don't accidentally deploying a cluster application onto somebody else's cluster and breaking their cluster accidentally. So that's where the zero trust application deployment model works. Then you have a separation of duties. Like app team is responsible for deploying app, and the platform team is responsible for deploying the infrastructure for you. Then you have secret management integration. Then you have centralized policy enforcement, drift detection and blocking, and private manifest repository. But today is my focus around, if you go to the next two slides, around zero trust application deployment and the separation of duties. So now the first things come up, how you have to separate the concern between application and deployment. And that is I actually added in the next slide. So if you go to the next slide, and that's where that's the summary of the role and permission granted to the team. You have an org team, and then you have org admins, and might be orgs have read-only permissions for the project. Might be you have not one project, but you have different projects. Might be you have, let's say, do you have projects in EKS cluster? Then you have project in AKS cluster. Then you have project in GKE clusters, and then the project is divided among teams. So that's hierarchy becomes completely complex. But look at the simpler version. How look at difficult. So you have orgs by permissions for the project, and then you have infrastructure and workspace. Workspace is actually give you the access to the cluster you're actually working on. Then you have a project admin and the project read-only permission. Then we have a workspace and the infrastructure. So infrastructure admins can actually, let's say, can create the cluster, meaning they can install third-party apps for you, GitOps, policy agents like Kyverno or Open Policy Agent, or then actually deploy third-party like they have Bitnami for secret management. They're going to add it for you. And then the developers, what they do is they have access, and then they have the access to the cluster, and then they deploy application on top of it. And remember, in a team, in an organization, there's not a one developer. There are 10 and 100 and 1,000 of developers. And Kubernetes give you the namespace concept, meaning there's a namespace, you can actually access the same namespace that belong to you. The way you actually access the namespace with a permission, we call it RBAC, role-based access control. So basically, a namespace is actually in a Kubernetes is similar sort of like if you have a house and you have different rooms from your for daughters, and let's say if you're a house owner like dad, and you have daughters and sons, you actually have separate rooms for the daughter and son. So basically what son can see only the resources they have in their area of a room, and the daughter can see the or resources all they see in the area of room, they can actually see it. So in the same way, Kubernetes have all the permission model. And what you can do is that if you want to deploy certain apps, we can give you the namespace and that's belong to you. And what you do is you actually add your application and all the things that actually application or what actually project you're working on that. And the way you can give access to those resources via RBAC. RBAC stands for role-based access control, and that's where your namespaces comes in handy. And we have in a Kubernetes we have called namespace based permission versus cluster wide based permission. So the namespace said, like if you have a kubectl getNS, that's a namespace orange. In an orange namespace, SIME can only be the person within an organization can deploy application on that namespace. If accidentally Sharar access the same namespace, he get a permission denied error saying you don't have permission to access the SIME namespace. So the way we can actually stick something. But there are criteria where we have a cluster-wide resources. So namespaces just belong to the developers, but the cluster-wide resources being you have storage, you have networking, and that is an organization-wide resources. And that is actually basically the job of the infrastructure team. And within the infrastructure team, you have storage team, you have security team, you have networking team. We are to give restriction to the infrastructure related domain specific needs for those percent of the task. So now if you go to the next slide, please, Shahryar. So one more. Yes. No, go back. Yes, thank you. So right now, if you look at, you have cluster in geographical centers. You have some clusters, let's say in AWS region, US East. You have some cluster in US region West. You have some cluster in digital oceans. You have some cluster or might be in Civo Kubernetes cluster or Civo Cloud, or you might have some cluster in, let's say, Azure AKS and GKE, and you want all those clusters to have a centralized visible location for me to track those in. And that's a very small screenshot I've added. What I want to see, infra admin, as I want to see the permission I granted to the development teams, how they are accessing cluster, which area of time, like if let's say if they access the cluster 8 a.m. in the morning, and what command he actually wrote in the cluster, actually declarative command he used to span up the cluster. If something bad happened to my cluster, as an infrastructure admin who has responsibility to make sure infrastructure will be visible and will be available for all of the application team, regardless of what area of time we're actually accessing. But in order to make the highly available cluster, I need a centralized visibility tool. So basically, if I look at the dashboard, see who can access the cluster, what the latest command that broke the cluster, and then I can look at the permission. What the command actually broke the cluster, and then I can drill down in the issues and then actually do the forensic and make sure the cluster is back to the normal. That is my need. I need a single administrative PAN for infrastructure. Is my first area of requirement, security access. Now, Shahryar, can you go to the next slide, please? Yes. So in a Kubernetes cluster, You have cluster life cycle management. You need visibility. You need who can access the cluster, what time is accessing, what command he wrote. And then we need troubleshooting, and you need enterprise wide dashboard, alerting notification, and you need Prometheus and Grafana for centralized visibility and monitoring. Now, if we go back to the next slide, Sharyar, and I think if you come with a mindset of not every dev and ops team member needs an unrestricted ability to create, delete, and modify resources, create, delete, and modify resources, then what's come up with that mindset? You spend a lot of time with single administrative pane. You spend a lot of time in enterprise dashboard. What end up happening is you need less troubleshooting. You will come towards the area, you come towards the goal where you have less alerting and monitoring, and you look towards the area of adopted integrated monitoring. So in the next slide, I tell you, if you come up with a mindset of not every and DevOps team member needs the unrestricted ability to create, modify, and delete Kubernetes resources, this mindset gives you less troubleshooting, less alerting and monitoring, and being prepared for the monitoring, and you have visibility in the single administrative plane and enterprise-wide dashboard. Now, Sherry, I can go to the next few slides, and then I straight go to the yes, next four, and that I think I can get. Now we come into the place of the challenges associated to the control access. How do you access the cluster? What are the traditional approaches you have? How they actually lack today? Where they leave, where they see some kind of visibility? And can you go to the next slide? And we start with our journey of access management via Bastion. What you do is you install some of the Bastion controller in front of your Kubernetes, private Kubernetes cluster. You SSH into that machine, and that machine where the Kubernetes cluster is running, you will able to access those. But the issue, the huge issue, is everyone has the same kube config file, meaning if somebody mess up the cluster, the entire organization is in the hand of the recovery team to give back to the previous state of like the cluster, and you will end up seeing a very much fighting. And I see a lot of the in early 2020, a lot of being spending a lot of time in backend recovery tool, because this has happened very often. And you also have a large attack surface since entire private network accessible from Bastion. The next one, and that's another challenge with the approach called jump host. What you do is you create a jump host, meaning let's say you have another machine dedicated in the public area. You can access to that machine. That machine will eventually actually access to the private cluster where Kubernetes cluster is running. But we've done something good in here, but the problem is some similar to the previous one. You have same queue and config file, and you have a YAML secret and all the dumping ground of YAML and secret management that you have to take to worry about. Then there's a large attack surface since the entire network is accessible from Bastion. The same approach, different design, but the problem still remains the same. The next one is on the next slide, and that is access via VPN gateway. That is better. I see some of the companies, some of the people are still using Kubernetes access management with this approach. It's kind of have some of the tool associated in the market right now, but the problem is that it will cost you $1 to purchase and operate. You need a team dedicated for the VPN and who can actually give you access to the cluster. So it's a good one, but there's so much cost associated with it. Remember, if you are accessing the cluster in the AKS, EKS, GKE, if you accidentally create some of the resources in the EKS, AKS, GKE, that will pile up your bills. So it's a good approach, but there are cons associated related to the need of VPN gateway per data center. Every data center required of one VPN, and that's need a huge amount of resources. Then you have a user need of VPN client on laptop. You have a laptop to connect to the VPN, and the VPN connect to the data center. And as I said, there's a $1 there's a money and there's a cost associated with this approach. And why did hackers? Since entire private network, all IPs, all protocol is accessible from the laptop, which accessing the VPN. So that is another bad way. So in the next slide, if you go to the next slide, Shariar, you see the manual approaches will fall apart. And you can totally understand this because you are not accessing the cluster one. There are tens and hundreds of access cluster that you need to deal with on daily basis. I work in a team where we have access cluster in EKS, GKS, DigitalOcean in many different places, even on data center and remote and agile locations. So we can't rely on the manual solutions to fulfill our need. That's where we headed towards the key takeaway from the challenges and heading toward the solution, the open source solution that can effectively help you become some of the challenges. In the next slide, I'm talking about the key takeaways. Number one, you need to remove the cognitive load from accessing cluster by cluster. You need to remove the manually jump host or VPN approaches because entire fleet, entire network is actually on the verge of one bad access, one bad command to the cluster. Then you need $1 to purchase and operate, and then you need some kind of custom tooling to audit, because the reason why you're auditing is you're spending a lot of time in auditing because you know things going wrong and wrong in a very horrible way. So that's where you can actually work with identity providers and auditing mechanism to solve the needs. And then all these are human friendlier, humans command type, and they can actually broke in some way. So basically, you have this. This is actually error prone, increase the risk of breaches as the number of cluster grows. So let's circle back our communications toward an open source solution that's called Paralus and the CNCF sandbox solution. How this solves some of the challenges, or we can dive in to see what the model where Paralus operate in. So Shariar, can you go to the next slide, please? Yes. So meanwhile, before I'm starting jumping into the open source solution, if you have some question related to the access management, because I know you have 10 of them, don't hesitate to ask. And yes, don't hesitate to ask, and I will like to cover. So let me give you some backstory of CNCF Sandbox project, because I would like to dive into the intricacies of how the project evolved. I've worked with a lot of the open source projects in the communities in the past. So I would want to be a very listener around the backstories of the project. So I talked to one of the team who's actually managing this open source solution, and this team is called Rafe Systems. And I talked to some of the team members why you see a need of an open source solution and why you actually are donated to the CNCF. And they spoke about in our Rafe Kubernetes operation platform, we have multi-cluster management that the client is using. We have GitOps for Kubernetes. We have visibility and monitoring tool, having a single plane, a click of a button, and then the policy and Kverno open policy agent features like add-on. And then they have a Helm dashboard in their platform. Then they have a cluster blueprint, drift detection, and all of the features that are listed in is actually a part of that platform they're actually providing to the customer. And they tell me that one of the features their client is loving about is zero trust access, meaning the way they're accessing the cluster is zero trust, meaning no rotation of kubeconfig file, and there's a no rotation of RBAC, some kind of thing, is something handled automatically. And they see all of the client are accessing like Rancher cluster, OpenShift, main upstream Kubernetes, EKS, GKE, or Azure, and all these running in different data center, AWS, Azure, Google, remote, or Azure locations. So they tell me like all of the cluster approaches and all of the access management become a very difficult for our customers. And they like our feature around zero trust. And what we've done is we'll see if the plethora of people have already seen a demand, why not make it an open source? And other people can use the same feature to solve some of the needs. In the next slide, I'm talking about how the Paralus model works. So basically, if you are accessing the cluster today, how this approach works is You can access the cluster from kubectl CLI, Rafic console, or browser-based kubectl shell or kube API client. What ended up happening is you accessing the Paralus server. And Paralus server is a monolith comprising of many components, having a creatus for user identity, meaning if user log into the Paralus, we actually preserve their identity, user credential, and login. We use creatus. We have a bunch of other Paralus core component. So we separately combine those and call them as a Paralus server. So when you access the cluster, the first thing up, you talk to the Paralus server. So there's a no rotation of anything. So then there's a step two. You will log in via, let's say, GitHub or Google or any identity provider like Azure AD or anything you would like to access, or even you can use Okta to log into the Paralus dashboard. So you log in, and then you will assign we will assign you a permission, what permission this user has in order to access the cluster. The next thing that will happen, we will create a service account, ephemeral service account. When you bootstrap the cluster in Paralus dashboard, there's a relay agent installed in front of your cluster. This basically install configure service account token for you, and then you can access the cluster. Then the service account token is actually added in the Kubernetes server, API server. The next step is you're actually accessing the command kubectl get pod. You can see the pod. You can see kubectl get deployment. You can see the deployment. If you don't have permissions to see the deployment in, let's say, orange namespace that belongs perfectly to me, then the access denied error, because we have already added some kind of authentication mechanism in Paralus, so you don't deal with RBAC or role-based access control. So that's the architecture we have. And this architecture gives you the unified trust, secure access via network terminal, immutable audit logging. When you access all these commands, there is trial. You can see who does what time it takes for the command to run, and all these kind of things are visible in the Paralus dashboard. So basically, with this tool, the promise here and the motivation is toward zero trust model, governance capabilities, and integration, meaning comply with DevOps policies and reduce attack surface with data centers, and centralize cloud credential, including IAM policy and service principle. So now you can go to the next slide, please, Shariar. Yes, so now the scenario becomes, I want to access the Cloak Kubernetes cluster using web browser-based service account token and a federated RBAC. I need centralized visibility, centralized audit trail of all kubectl activity. So basically what I need is, I need a secured access with a clock-based Kubernetes environment, meaning I can access the cluster, jump in, and then I remove. And that's, I need a service account token for federated, and I need to see a centralized visibility of all kubectl activity. So that's the scenario of where we think Paralus can best fit in. And if you go back to the next few slides, and then I go straight jump into some of the demo spot and tell you how these things look like in real world. So Shara, can you go to the next slide, please? Yes. So that is, if you look at the paralus.io website and go jump in there, you see all the information available. Is this an open source product? I want to see some of the contribution from the community members, because what we like to see, how community are dealing with the challenges of access management. What's the problem you're facing? What feature you want to add in? So basically, as of today, we're giving you the custom roles, user and groups. If you log into the Paralus, we have custom role associated with it. And you can actually change and revoke permission on the fly, meaning if somebody from the team member leaves the team and then join in again, there's always a hustle. Then the in compliance team came up and manually remove his permissions. But that is not the case with the open source tool like Paralus. The permission model is actually a very automated one. You can actually dashboard and revoke permission. Then we have a single, meaning you can use GitHub, Azure AD, or Okta to authenticate to log into the system. And you have an audit log of kubectl command history. And a modern, we have a GUI, we have a PCL tool to access the Kubernetes cluster, and we have a API. So Shariar, I'm hoping I'm not lost anyone. So can I share my screen and give you some demo?
Yes, sure, sure. Okay. Let's wait for some time. Um, okay, so if you guys have any questions till now, you can just comment it out here. I think there are some questions coming up. Okay, let's wait for the speaker. So yeah.
Oh, sorry guys,
No issues.
for disconnecting again.
So
So Shariar, thank you. So Shariar, I'm just sharing my screen. So while I'm sharing my screen, I previously clicked the wrong button and I disconnected. So sorry for that, people. So actually, let me share my screen. I'm sharing my entire screen, and I want to give user and the listener a walkthrough of how this thing work. So unable
yeah,
to. So Shara, can you give me access to share my screen? Currently, it's
actually it
giving me some
should.
errors.
I think you should have the access actually. Okay. Uh,
Oh,
can you please try
okay.
joining? Yeah, using that link.
Yes, sure. Sure. So I'm rejoining.
Yeah, sure. Okay, sorry for the issues, but I hope you guys will wait for the demo part because now Sam will actually show you the demo, like how it works basically. Okay, so let's add him again.
Yes,
Yeah, you can try now, I guess.
yes, absolutely. I think there's a one question in the chat from what is the best tool for managed Kubernetes? Is it the question, Sharia, in the chat?
There are others as well, but yeah, it has been one question, like what tool best for managed KTS cluster.
Yes, absolutely. So I think like if actually I think right now the motion is there's a revolution, we call it. The momentum is towards managed Kubernetes cluster, because spinning a Kubernetes cluster locally is taking a lot of our time and effort, and all these things we have to do it manually, because service Kubernetes is not just about just Kubernetes, but the entire ecosystem is built around that. So currently, I see people are building platforms on Kubernetes infrastructure. If you look at the right now, there's a GoPort, there is a OpenShift already in the for a very long time. Then we have there's a tool that I know. I work with a company called Rafi Kubernetes Operation Platform, and then there are a bunch of others who exist. What job is to actually give you the Kubernetes inside a dashboard and basically pick and choose the services what you like. If you want to use service mesh, oh, here's the button for you. Click on it. Service mesh added behind the scene, and let's focus on the app, the business that you're actually working on. So that's where the motion is actually helping on. So I think right now there are very overlapping, and there are a very overlapping for that. So if you want to manage Kubernetes locally and to want to see a centralized visibility, That's because the question is having two angles. Number one, I know the Kubernetes is complex. I want to have a managed tool that give everything in a single plane of class. That is what a tool I'm talking about. If you're talking about just a tool that give you visibility and you can see how the pods and replica set and daemon set are listed inside the dashboard. Previously, we have the Lens open source project, but now it's becoming a more of a commercial one. So K9S is a really good one, and somebody actually chatted on there. But the K9S is give you is a terminal base. You can type commands, the terminal based access management, meaning you can look at the dashboard and see how the pod deployment replica set and all these things behave. So if the managed Kubernetes, go look at the platform tool that people are building on top of Kubernetes. For the local development need visibility, Neil, go for the K9S. Yes,
Yeah.
for the product level. Yes, I already tell about. If you want to have a Kubernetes cluster, service mesh, GitOps, Prometheus Grafana, Ingress controller, if you want to lift off this responsibility to somebody else, what you do, go for the some of the tools I mentioned already mentioned. Go to the, let's say, there are a bunch of them like OpenShift, there's Rancher, there's a Rafi Kubernetes operation platform, there is a Coport, then there's Mia platform, and there are few others like Weaver's platform, few other like you can name it. It's very difficult to tell which one is the best, but these are the options exist. And let me know if you have any question related to that, I can answer. So any more question before I jump into the demo, and then we can conclude the part.
I guess this
Does
question popped up.
Parallus has high availability?
Yeah.
So how the Parallus is actually, yes. So how the question is actually related. So if you access the cluster, there is a lot of the time is actually you access the cluster config, and your kube config is actually used by all the team members. Your kube config is members, and that's a bad up with a config file in healthy user. Centralized server. That centralized servers is actually centralized server access that actually accessing the cluster behind the scene. So basically, the question around like how do we avail how does the Paralus become highly available? This is a one lacking point, and that is accessing the cluster. So basically, there are some permission you can actually tap in the load and make it tree of the past server, and then actually access the cluster behind the scene. Does I lost somebody? You?
I guess your video is breaking down actually. Yeah. Okay. So I guess you can start with the demo, and if mhm. Okay. So as we assumed, yeah. Sorry for the issues because our speaker is facing some internet issues, I guess. So sorry for this issue. Okay, let's wait for him to join in again for the last part, like the demo part. Yeah, let's see. So yeah, he has joined. Let me add him to the stream. I guess. Your screen is freeze. I guess. So yeah. Hello, Saif. Can you hear us? Yeah, this has been an issue, I guess. Let me wait a bit. So, is it possible to get the slide deck right? Okay, so yeah, I will talk to the speaker, and if it is possible, then I will add these slide deck to the stream, basically into the I would say is YouTube live. Into the description, you might see this slide deck. Okay, so yeah, awesome. Okay, so yeah, as we can't, I guess we can't continue the session if this seems like this. But you guys can share where are you, where have you joined from. So yeah, in the meanwhile, yeah, I can see Sam now.
Okay, okay. So I don't know why, but it's actually reloading for a long, long time. Even I'm talking, and it's got me disconnected right now. So this is my best experience. I usually do some kind of hosting on other platform, and meanwhile, if you want to do some deep dive content, I have a YouTube channel called Cloud Native FM, and there's a lot of the talk related to Paralus is available. There's a question around how does the Paralus give you some kind of availability. We have an entire session on that on the Cloud Native Podcast YouTube. So make sure you actually join it and see the discussion there. I hope things got work right now. I give you a very quick demo, and then you actually, and thank you very much, Neerav, for actually sending the Slack channel in here for so people to join us. If you have unanswered question here, please go here. And if you have some wonderful communities building up, I'm going to answer those as well. So I hope I can have permission to access my screen so I can literally jump in very quickly and give you some very good highlight to it. So I think I have to rejoin in again because of the I disconnected previously. So that's a design consideration. No worries. I will be very quick and it's a very short demo and I will back.
Okay, yeah, thank you guys, and yeah, thanks, for sharing the Slack channel. And in the meanwhile, so what you guys can do is there is actually blog pallas.io blog. So this is what Sam has shared with me. Let me share. Check this out. Okay. Okay. You guys can check this blog. I guess. Okay.
Sure.
Okay. I've
So
added you to the
thank
stream.
you. So
Yeah.
let me quickly share my screen again. And there's a very short demo. We hope things work right now. Sorry, people, for some kind of. I'm still unable to share my screen. No worries. What I do is, Sharon, can you go to the Paralus repository? Because there's some videos in there. We can actually use those as part of our discussion. So paralus.io, and there's a GitHub link there. You can go there. There's a very GIF added there, so I can walk through people how this actually work in the real world, because that's people who want to. We have auction question. So if you,
Okay. Okay. Let me
yes, no worries, no
go to
worries.
the here.
So, guys, if you're actually, we have while a share is actually sharing this, if you go to the Paralus website, Paralus is now actually listed in AWS Marketplace. Is actually available into the Civo Cloud. We recently added, and it is also available into the Digital Ocean. Why this is actually super cool? Because sometimes we feel like installing and cloning a repo is kind of overwhelming. You install Helm, install, and Paralus is installed, and sometimes bad things can happen. With the managed offering like AWS MP, Marketplace Extension, what you do, go to the AWS Marketplace, click on the Marketplace, is a one-click installer basically. So basically, when you install, go to the EKS cluster, look at the security in the AWS Marketplace security section. Inside the security section, you see a Paralus. Click on that, install it on your EKS cluster. Once you install your EKS cluster, you see some of the component related to Paralus added. There are some connector, there are relay agent, relay server is already added. So this is a website we're talking about. So the next step is, Shara, can you go to the GitHub right now? If you go to the GitHub, click on the GitHub, and I can walk you through some of the step in the. Yeah, I think we have added a GIF in here, somewhere in the down, in the repo. Can you go there quickly? Uh, Contribution, author, Paralus website. Let me I share one with you. So I can share one with you quickly here so people can look at how this thing work.
Is this the JF we are
Uh,
talking about? Features? Yeah.
yes, this one. So can you actually make it a more bigger? Like if you click on it, there is a separate. Yes. So what? How does the Paralus work? Is first thing first, you log in to the Paralus via GitHub. So the first step is you go to the Paralus help install Paralus, and at the dashboard you actually locally run into the console.demo.parallels, and then you actually access the access the Parallels dashboard. The next thing is how do you actually log into the Parallels? You can actually use GitHub, Okta, Azure, or any favorite tool you can do it. Next step is you actually bring on cluster onboarding process. Click on the cluster and import existing cluster. Then the import existing cluster, remember we adding the relay agent in front of every cluster. We are adding relay agent in every front cluster. So when you import the cluster, we give you the bootstrap.yaml file. When the bootstrap.yaml file you downloaded, let's say kubectl dot yes. Thank you, Nirav is also added on the YouTube as well. This is a talk from Nirav on the case city Bangalore. There's a video is added there. So basically, let's you and actually download the bootstrap.yaml kubectl bootstrap.yaml, and then the relay agent is actually added into the cluster. What the relay agent does is providing you the service account token for accessing the cluster. Meaning, when the service account token is actually granted, added in the cluster, you don't need a kubeconfig file or all of these or rollbacks and the manual processes. Basically, you can access the cluster with ephemeral service account token. If you install kubectl catpod, the Paralus server actually lift off this request to the relay agent. Relay agent will actually give you the service account token, and that service account token has a permission, means he can access the cluster as an admin, as a read-only person, or as a readable, writable person to access the cluster. So with that model, you can actually access the cluster and list all kind of resources. Let's say if you want to add more granularity and give me permission or revoking permission, go to the Paralus dashboard inside the settings and go to the project setting, and you actually remove the permission of sign from this cluster, and in that way my permission got revoked and everything back to the normal, meaning there's no manual steps involved behind the revoking of permissions. So that's how Paralus is actually works today. We have so many new requests coming up. There are some issues related to it. Currently, we're working on how you give you the centralized visibility using Prometheus Grafana tooling. So you can the dashboard look more shinier and for you. So we recently added CO Cloud. Make sure you actually access the CO Cloud cluster and let us know your opinion how this works. So Sharar, over to you now. Look at if you have any more question, and then we wrap up the proceedings. And you can share your screen, and we can actually give some people a final places to look for some resources for Paralus.
Okay, so yeah, I guess people can now ask their questions because we have just end up with our sessions right now, right? Okay, so yeah, I guess there are some questions that you have already asked, but yeah, few questions that should be that might be added here is I guess I'm going to ask you some questions like yeah, how can organizations effectively implement role-based access control in their Kubernetes cluster? So what's your opinion on that?
Can you repeat a bit? Can you repeat again? Just if I lost a few.
Okay. Okay, so how can organizations effectively implement role-based access control, which is basically RBAC, in their Kubernetes cluster? So how can
Yes, absolutely. So
organizations
there's a
do that?
manual process. Remember RBAC, why RBAC permission model is works. Remember, we have a namespaces concepts in Kubernetes. Namespaces allow you to see the resources that belongs to you. How do you actually, how do you actually like audit? How do you actually control? Is you need a role-based access control, and that is provided to a namespace. So what is so
Mhm.
the role base is actually telling you have a you are, let's say I want a read only access to the namespace orange. I create a role, and then I create a role binding, and that role binding belongs to SIEM. Because remember, in Kubernetes is a no user concepts in Kubernetes. Like SIEM is a user can't access to the this per, a resource or that. The user is not added in Kubernetes as a resource. So if that's a limitation, in our come to limitation, we need a role-based access control. So role-based works like you first create a role saying you can access the cluster and have a read-only permission to the orange namespace. How do you bind this role to me? You create a role binding object, and then in a role binding object, you say that this is a resource name kind. Kind is a resource, let's say a resource is a namespace. In that resource namespace, you can't see a deployment resource, and if you see it, you can have error. So that is how this manually works. It's a lot of moving pieces between them in order to, and I think people is moving toward manually accepting manually creating R back toward automation approaches like Paralus. What the Paralus does is exactly the same what Kubernetes is actually doing, is giving you the R back model but hiding the R back detail from you. So basically what it does is you log in via GitHub user or Google account or any tech account, and you log in. When you log in, we create a role for you. Let's say in this project and this resource, you can actually access this namespace and you can see a deployment. And that is actually added for you on the fly when you actually access the cluster. So when you access the cluster, being an admin, being a developer, I don't have any worry like if I'm accessing a bad thing or bad access, because I only have permission to what already provided to me by platform engineering team. So I think the question right becomes now, if you are manually doing it, it's great, but manual process fall apart and it's very complicated. Like is a hierarchy is so complex and is a learning curve behind it. So I see people are moving towards some RBAC solution. Paralus is one of them. There's a Cubescape that give you the RBAC visualizer, and there are a bunch of other in the market that give you the automated framework for RBAC management.
Okay, that's awesome actually, because you have already mentioned about the RBAC, and right now, yeah, this is how it works. So again, there can be another question like regarding this, like are there any specific tools or framework that you recommend for simplifying and enhancing Kubernetes access management? So from your own opinion or experience, like anything you would like to mention.
Yes, absolutely. I think like there are some different models right now in a Kubernetes we have. Somebody is using toward the CRD model. Like you have a controller installed in the Kubernetes cluster. What it does is if somebody accesses the Kubernetes cluster from a wrong permission model, it detects it and it see from the policy like this person don't have permission to do these kind of stuff and it's blocked. So meaning in front of Kubernetes, and it's front of the Kubernetes door. So meaning if you want to bypass this door, there's a controller in front of you that is actually preventing you to do some harm in the cluster. That's where we tools like in the past we have a dietary tools that give you some kind of like this YAML specific thing, like you can't have a bad YAML actually in place in the cluster. So they actually block you for doing that. Instead of waiting for the cluster to applying the cluster, and the cluster tells you like there are some misconfiguration in here, it's telling you beforehand. So these are the controller inside the Kubernetes. I talk about policy engine like Kyverno or Open Policy Agent. These do these kind of the gatekeeper thing. And there are some tool that is actually apps and DevOps tools. Like this, they create separation of concern between application team and DevOps team. And Parallels is actually one of those. And what is Parallels is allowing you is actually platform teams can actually create permission model in the Parallels dashboard. And the app team actually use the same permission model to access the cluster. So that is actually overlapping, or you call it separation of concern. And then there's a gatekeeper tooling in Kubernetes. And then remember, access management in Kubernetes is as complex as landing something into the moon, because look at it, you are accessing Kubernetes as CSI, CRI, CNI, service mesh, GitOps, Prometheus, Grafana, observability, so much. So having a one bad command typing, then the forensic begins. Oh, is it a runtime error? Is it a CRI error? Is it a CNI error? Is it a CSI error? Is it a service mesh error? Is it a GitOps error? So those so much in place. So I think it's a better recommendation to be a prepared for security preparedness up front. Don't rely on day two or day three. That's what we call a security preparedness with some of the open source tooling like Kubescape or Paralus and bunch of other available in the marketplace. So I think having some of the tooling that provide automation is necessary. But if you want to do it manually, you can, but you end up in a situation where you spend a lot of time configuring, managing, and deploying, and less time in the business domain. Like your job is to actually create some application that business consume and therefore do their work. So actually you have very small amount of time to think about those things. But I think having some automation tool or open source tool give you some good kind of visibility.
Okay. Oh, yeah, that's a good explanation. Yeah, awesome. So I would like to add one last question, and it would be like, how can organizations strike a balance between granting developers the necessary access privileges while maintaining security and minimizing potential risks? So yeah, what
Yes,
is your
absolutely. I
opinion on
think
that?
I think right now what the organization typically need is, like, I think a lot of the enterprises is building Kubernetes platform, and these platform has in baked in functionalities. Like I tell you, you have a zero trust security, built in policy and enforcement, built in GitOps and drift detection tooling, built in networking tooling as well. What organization is doing right now, they adding a tool called zero trust security. What this tool does is similar to the same. This tool is actually added in the platform. What the platform team is actually do, and their job is to actually create a permission model for the application team, because the platform team's job is to make the life of application team more easy. After they actually doing something bad with the cluster, they're telling them upfront, you have these rights, and if you need more rights, let's talk to me. I will give you more rights. And if you need more rights, let's talk to me. I will give you more permission. And if you need more permission, let's talk to me. So what I do, I give it to the more permission model, and then you work on the security lead. So yes, so I think a stock. So I will repeat again. So basically, what organization is doing right now, you have a platform, and that the platform has feature like zero trust security. First thing first, separate the concern between two teams. Platform team needs more ownership than development team. And remember, I tell in the slide as well, not every dev and ops team member needs an unrestricted ability to create, delete, and modify resources. We all agree. What we do, we will tell platform team, your job is to create permissions for application team to they can do their work best. What they does is they can give guarantee like, let's app team, you have a read only access to the resource name called deployment. In that deployment, anybody can actually uh, list their deployment, but if that person is from the next another team, he won't access to it. So you can first thing first separate the concern. So you will actually look at the permission model and hierarchical model where you can give like, here is a separation of concern. When you identify the separation of concern, next thing is that look for the automation tool that you give you the automated RBAC, centralized visibility, and kubectl trace of all activities. Like if I type kubectl get pod in a dashboard, all of my activities will log. If something bad, let's say my last command kubectl apply dash f broke something, it's very easy to do a forensic out of it. Separation of concern, number one. Separation of concern, number two. Automation RBAC, automated RBAC. Number three, centralized visibility, centralized tracing of all kubectl activity. Number four is do some kind of and look towards, go towards policy and governance for compliance of your organization. Try to bring in compliance and a cultural shift and what your organization, how your organization is set up, and then you actually create another loop out of it. So I think these are the basic requirement for anybody using it. I hope you this answer your question, and thank you very much people in
Yeah.
the chat as
Yeah.
well if this information look useful for you.
Yeah. Yeah. Awesome. Awesome. Thank you so much for these informative answers. Yeah. I guess that's how we can end our session now, right? If there are any no questions left, we can end our session. Yeah. Thank you. I guess so. Yeah. If you would like to add anything, you can just mention right now, like something like yeah, Slack or something like that.
Yes,
You can.
absolutely. Thank you.
Anything from
Absolutely.
your
Thank
end?
you very much for I see a
Yeah.
wonderful audience today in the chat today. And number one, I can tell you like I also have a YouTube channel called Cloud Native Podcast, and at the rate Cloud Native FM is a Twitter handle where we have 80 plus episodes, and I'll continuously monitor, do a forensic of how and research around how other people feel like in the domain of Kubernetes. And if somebody watching and we have a same domain and want to share their story, do let me know. We can conduct some podcasts on my YouTube channel as well. Also, we have a Cloud Native Islamabad community where you can look, if you look type search Cloud Native Islamabad on YouTube, you see a bunch of very informative workshop on Kubernetes. So do join those as well. And if you're working on some open source project and wanted to be a part of CNCF, or if you are actually going to KubeCon, if you have any interactions, if you want to see me, I would love to communicate, love to hang out, want to know your opinion so I can make Paralus a better project. Thank you very much, Shariar, for inviting me. And I really enjoyed the time here, despite of some difficulties.
Yeah. Yeah, no issues. I think this does happen in occasionally, so there's no problem. Yeah, thank you so much, Sam, for your awesome session. Yeah, let's just end our session now. Okay, so yeah, let's okay, let me take you to the backstage then. Thank you so much. See you soon, Sam.
Happy
Yeah.
one. Bye bye, everyone.
Okay, so yeah, so thanks everyone for joining the latest episode of Cloud Native Live. We enjoyed the interaction and questions from the audience. So thanks for joining us today, and we hope to see you again